This is Dr. Holt. In this video, I'm going to work this problem here, and what I have here, I'm given the mass of the Earth is 5.98 times 10 to the 24th kilograms, given its radius, and I want to find out how much work must an external force do on a satellite to move it from a circular orbit where I'm 2 REs of the radius of the Earth above from the center of mass to 3 REs if the mass of this satellite is 2,000 kilograms. Now, what you got to be careful here when you're doing these problems, especially on an AP exam, is to note whether or not you're in orbit. If you're in orbit, you got to do these differently, as if you're just going to talk about the work as far as moving an object from here to here. It would be different. But now you're in here, since you're moving from here to here and you're in orbit, you also have kinetic energy, because you're going to have some type of velocity to maintain this orbit. I'm just going to go back to the general equation and talk about this. We know that, let me get this into black, that we know that the kinetic energy initial plus the potential energy initial plus work must equal to kinetic energy final plus potential energy final. Now, if we solve for work, I'm just going to isolate work, we can say that work is equal to KE plus PE. Put this in parentheses, these are final values, minus KE plus PE initial. So what we're going to do here, we're going to take what's called the mechanical energy here. This is the mechanical energy final, and we're going to subtract the mechanical energy initial. And that's going to give me my work equation. And that's pretty much all we're going to do to solve this problem. This problem is actually quite simple. Now we know for an object in orbit, scroll down here, we know for an object in orbit that the mechanical energy for an object that is in orbit is going to equal to minus 1/2 times big G times mass 1 times mass 2 divided by the radius from the center of mass of the larger mass. So I'm going to be using this equation here. I will find out what the mechanical energy is initial first. So I'm going to get minus 1/2 times G, which is going to be 6.67 times 10 to the minus 11th. Again, I'm going to drop off the units because this problem would go way out across the screen if I did that, times the mass of one of the objects in terms of kilograms, and I'll use the Earth. That's going to be 5.98 times 10 to the 24th times the satellite mass, which is 2,000, and I'm going to divide that. I'm up 2R. I'm going to do 2RE. Now we know, given the radius of the Earth is 6.37 times 10 to the 6th, I will put 2 times 6.37 times 10 to the 6th. If I run that value, I will find out my initial is going to be minus 3.108 times 10 to the 10th joules. Now I find my mechanical energy final. To do that, I do minus 1/2 times 6.67 times 10 to the minus 11th times 5.98 times 10 to the 24th times 2,000 divided by my new radius. And my new radius, again, we're doing 3 RE. So I put 3 in here times 6.37 times 10 to the 6th. Run that value here, put the equal sign up here. That's going to give me minus 2.0872 times 10 to the 10th joules. So again, we know that work is equal to final minus my initial. So we take those values, we take our final, we get minus 2.0872 times 10 to the 10th, subtract And make sure you do this, be careful with your minuses here that you don't accidentally make them both negative. Meaning I don't want to add the two negatives together. Minus the 3.108 times 10 to the 10th. Make that point better. When I do that value, I will get the value of 1.0436 times 10 to the 10th joules. Okay? Again, that's how you're going to solve work for moving one object in orbit to a different orbit. Very simple problem. As long as you, really the key to this is just go back to use this equation here. And you can prove that equation, and we've done that before in class. But if you memorize that equation there, this problem is very, very simple. All right, best of luck.